Hi, welcome to Lesson 28, Session 2. Today we're going to be continuing our work with two-dimensional figures and the categories and how we can break them apart. Today we'll be talking specifically about making Venn diagrams and tree diagrams and the different types of diagrams that we can make to classify our two-dimensional figures in by their attributes, putting them into categories. And so we're going to be working on pages 579 through page 582. So go ahead and turn with me to page 579 in your Ready Classroom Math Workbook. All right, so on page 579, we learned yesterday about a hierarchy. Remember, the hierarchy was the order, it orders the categories from the most general to the most specific. So the bigger the oval is, the most general the shape is. Remember yesterday at the end of the lesson, I don't know if you remember, but I showed you this hierarchy. This happens to be a tree diagram that you're going to be learning about in just a bit. And the most general is up here. Every shape, every single shape that is underneath a polygon can be classified as a polygon. That's why it's the most general. Now, the most restrictive is a square, because a square is the only shape that is a square. None of these other shapes can be classified as a square, which is why it's at the bottom of the hierarchy, because it goes from the most general down to the most specific. Now, in a Venn diagram, we have the most general here all the way into this tight, much smaller oval to be the most specific. So it says here, ovals A through D in this Venn diagram list attributes of 4 categories of quadrilaterals. Use the terms below to fill in the names of the subcategories from most general to most specific. So they've already done A for us. It says here, a quadrilateral has 4 sides. Every shape that is underneath a quadrilateral will also have 4 sides. So now we're going to look, and we want to know between rectangles, squares, and parallelograms, which of these 3 shapes has 2 pair of parallel sides, and it's the most general, meaning it doesn't have very many rules. We just know it has 2 pairs of parallel sides and it has 4 sides. That's right, it's a parallelogram. Because a parallelogram, we know that it has 4 sides and it has 2 pair of parallel sides. And that's the only thing we know about parallelograms. Now we need to go, okay, what shape has 4 sides, 2 pair of parallel sides, and 4 right angles? Okay, well, rectangles and squares both have all of those. But if we look here, we know that down here, it's going to have 4 sides of equal length. Which of these has 4 sides of equal length? That's right, the squares. So we know that the square is going to be the most restrictive. So the square has to be the smallest, which would mean the rectangle goes on line C. As I mentioned before, all squares are rectangles, parallelograms, and quadrilaterals. All rectangles are parallelograms and quadrilaterals, and some rectangles are squares. All parallelograms are also quadrilaterals. Some parallelograms are rectangles, and some parallelograms are squares. So that's kind of how it works. That the smallest circle can only be classified as the smallest circle. And none of these other shapes can be called a square, but you can call a square all of these other shapes. So I said that backwards the first time. Sorry about that. So again, a quadrilateral is sometimes a square, but not always. A square is always a quadrilateral. Now, when we're looking at number 2, it says, using this Venn diagram, we're going to use the Venn diagram and what we know about quadrilaterals to complete the table. We're going to fill in the subcategory names for letters B through D. And so we're going to do the subcategories and then write their attributes. So first we had quadrilaterals. The first subcategory of a quadrilateral is a parallelogram. A parallelogram has 4 sides and 2 pair of parallel sides. 4 sides, 2 pair of parallel sides. Then underneath a parallelogram, we have a rectangle. A rectangle has 4 sides, 2 pair of parallel sides, and 4 right angles. So as you can see, every time we move down and we get more specific, this is most general, most specific, we add another attribute as we move down. The final subcategory is a square. A square, like a quadrilateral, has 4 sides. Like a parallelogram, it also has 2 pair of parallel sides. Like a rectangle, it has 4 right angles. But the attribute of a square that not any of these other shapes has is it has 4 equal sides. So as you can see, as you get to be a more specific shape, you're going to have more attributes that make that shape that specific. Up at the top, it's a very general. It is the most general type of shape. All right, once you've got that written down, you can go ahead and go to page 580. All right, on page 580, we're going to learn about a tree diagram. Now, I already showed you my example of a tree diagram, but a tree diagram is a hierarchy diagram that connects categories and subcategories with lines to show how they are related. Write the terms below in the boxes of the tree diagram to the right to order the categories from most general to most specific. Now, this time, I think we'll go from the bottom up, starting with the most specific. Which shape do we know has the most attributes that make it the most specific? That's right, the squares. We know that squares have the most attributes, so they're going to be on the bottom. We know then up from squares, what did we have that was right above squares? That's right, rectangles. And then what was above rectangles? It was parallelograms. Remember, all squares are rectangles, parallels, and quadrilaterals. But only some quadrilaterals are parallelograms, rectangles, and squares. This is the most general down to the most specific. Now, we looked over here, since I don't want to turn the page back, this is an example of a Venn diagram. This is an example of a tree diagram. How are Venn diagrams and tree diagrams alike? How are they different? So they are alike because they both show the relationships between categories of two-dimensional shapes. How they are different is that Venn diagrams use ovals and tree diagrams use separate boxes. So we know that in a tree diagram, you start at the bottom and work your way up to get more general, or to get more specific, you work your way down. On a Venn diagram, the biggest oval is the most general. So you can even write that over here, the most general. And the smallest oval is the most specific. Finally, number 5 says this: Use a Venn diagram or a tree diagram to order the categories below from most general to most specific. Then explain why your order makes sense by describing the attributes of the figures share. So we're not going to do the explaining part, but we are going to go ahead and make a Venn diagram and a tree diagram using each of these shapes. So to make a Venn diagram, we're going to start, and I think I'm going to start with the most specific. That means which of these shapes it has the most attributes that it makes it specific. That's right. That would be the right triangle. So I'm going to write the word right triangle, and then I'm going to put an oval around it. Now, what is the next most specific? So would it be triangles or polygons? That's right, it would be triangles. So we're going to write the word triangles, and then we're going to draw an oval all the way around that shape, because all right triangles are also triangles, but not all triangles are right triangles. Finally, we're going to put polygon on the outside of that, because polygons is the most general. Polygons are any shape with 3 sides. So some polygons are triangles, and some of those polygons are right triangles, but not all polygons are triangles. Polygons could also be quadrilaterals, which have 4 sides. All right, now if we're going to do the tree diagram, well, let's start with the most general this time. What is the most general category? The one that almost every shape falls underneath. That's right, up the polygons. Now, underneath polygons, we're going to go to the next general, or the next in the order, and it's going to be a little bit more specific, but not the most specific. So next we have triangles, because all triangles are also polygons, but only some polygons are triangles. And then the most specific, using the 3 words that we've been given, is the right triangle. All right triangles are also triangles, and all right triangles are also polygons. So the most general is on the top, and the most specific is at the bottom. With that, you're going to go ahead and do pages 581 and 582 on your own. If you have any questions, you can always ask your teacher. Otherwise, I'll see you next time.